to develop a typeface. See, we are talking about a time, as you can see, in 1845, when there was no Microsoft Word, right? You cannot just select a piece of text and choose from a drop down that whether you want to prefer Calibri or whether you want to do the American typewriter, and the typeface will change. As you know, typeface means like how the different words and sorry, how the different characters in a language will look like when we are typing it. So at that time, people used to use wooden printing blocks for typefaces. Okay, so there are like these block structures or the kind of the schema that is designed, and within that the printing material will be poured, and when the printout will come, it will come in a particular typeface. So of course the options were pretty much less. So now how these moon types looks like this, as you can see. Okay, just understand these are the engravings. These are not 3D printed shapes. Okay. Nowadays, maybe you can 3D print actual A for A, B for B, although that may not be always very cost efficient or very legible for a person with visual impairment. But we are talking about a time when we have the printing blocks and engravings and a limited number of choice. Because see, like 3D printing, we cannot customize each and every page that will get print out. Once the block is set, it is set. Like thousands of copies will be printed out with that particular block. So, and the blocks cannot have infinite number of options, because all these things are okay.
అయ్యో డాడీ ప్రెస్ అంటే పెట్టండి వస్తాను.
Please mute yourself. Thank you. Okay. Okay. So all these would have come at a cost. So that is why moon type contains 9 basic shapes. Okay, so if you see in English alphabet, there are also some basic shapes, like by combinations of that strokes and all, you can make all the alphabets. So as you can see, this A is typeface like this, like with the engraving, which feels very similar to the A, like the actual Roman script A. B is like this small case B. C and D, when you see C, D, what is the most prominent feature that comes to your mind? This curved line, right? So in some cases like O, like V, it's look exactly the same, like Z, okay, like S, like the U. And in certain cases, like say M, N, these are slightly different typeface. Okay. So this moon type was basically used by people who lost their eyesight at a later stage, but they still remember how the words look like, how the characters look like, and maybe it was easy for them to relate to this. Okay, and this is also a map. Like see, for braille, you cannot print out an irregular structure like this. I don't know if it was discussed like from braille to picture, like how we can represent picture in for persons with visual impairment. Okay, for simple geometric shapes, we can use braille. Because we can say like it will be a bit complicated, but we can chart out like which points will be highlighted across certain rows, which dots, and then it will say give a like a triangle, like a quadrilateral. But something as simple as circle, how would you draw out? Something an irregular structure like these maps. So in those cases, whether or not you use moon type for reading or not, or braille, this moon type can come in handy. Okay, and just remember 3D printer was nowhere imagined at that time. So these are all it, but the embossings and graving on the printing block. Okay, so at that time also, like pre 3D printed the era also, there were efforts to make the maps are accessible for persons with visual impairment. Okay. So this will be there in the slide. So just as we have discussed, I wanted to talk to you. And I think you also, Tirthankar have also discussed the Nemeth, the syntax used for to representing maths in Braille. Yes, no? Anyone remembers? Okay, don't remember. Fine. Okay, so as I said, there are two videos which will be there in the slide. So let me start with the second video. Then I will go.
My daughter is definitely one of the driving inspirations of the work. And when I started thinking about how she experiences her environment, she often engages it in a very, very tactile way. And it just seemed to be the kind of perfect crossover where her need for a really strong sensory experience, we could actually cater to that based on the fact that we could make these textiles in, very, very particular ways that might address some of those challenges. So we have these tubes going in different directions. And what my daughter thought was interesting was actually taking a nosedive down one of these tubes. That sensory experience was so satisfying that she wanted to do it again. But to do it again, because of the scale of the structure, she needed me to help her. So we're able to create that kind of simultaneous, like, social interaction communication with sensory reward. One is being used at my daughter's therapy center. So that's like, our kind of target audience, children with autism, and using it on a daily basis.
Okay, so as you can see, 3D application of 3D printing, application of touch sensor, application of user experience, motion data processing, touch data processing, interaction. So everything has come together to make this piece of technology. And this kind of, as I was discussing about autism, that children with autism, they respond better to this kind of animations, the tactile senses that they can feel by interacting with the environment in their own comfort and their own way. And this fabric also need to have this 3D printing fabric. This also needs to have a particular touch sensation, to so that it does not agitate children with autism. So these kind of very technologies for playfulness and therapy is possible to make with the recent developments in different technical fields. And I don't know, it may be a very silly expectation, but it would be really lovely to see that if this KGP having so many tech contests and quiz and competitions if a person from different interest can really come together and make something like this, because we do not have anything like this in our schools with autism, with children with autism. And yes, till now we have to send children with autism to separate schools, because the regular classrooms are not very friendly to them, or not very understanding of them. So it will be really lovely to see any kind of efforts towards this. So let us move back to our discussion of technology. So last day we talked about different dyslexia apps, and I also gave you the video of MDA Avaz Reader. So just to mention another thing that you may have noticed, the MDA Avaz Reader is mostly for English. Okay. So language versatility is also a very important thing. So now this is a very bad picture, because it was difficult to capture it in a single picture. There can be an entire class taken on this, but we all know about brain computer interfaces, right? Although we know about the like either we know about them from our coursework, from our study interest, or from the sci-fi movies, that there is a effort going on to understand from brain signals that what a particular human being is trying to do or wish to do, right? So in a case of different disabilities, like particularly the neuromotor disabilities like cerebral palsy, what happens, the muscle movements are involuntary. That means that although what so for our case, what happens, we say that our brain controls our muscles, right? We think, although we may not realize always it very consciously, that we want to expand our arms, that you think that you want to leave the class by pressing the leave switch. Okay. uh, so our brain thinks that, and accordingly our muscle works. So the pathway between brain and our this motor neurons are intact. But for person with cerebral palsy, they have movements. So what happens, it becomes difficult for them to like think that okay, now I'm going to type this out and actually type it out. But or those who have say like prosthetic limbs and wants to do really find the work of art, maybe they have, maybe an artist has lost her limb and has a like prosthetics, and now the want to use that prosthetics to paint again. So these days you might have heard these terms: intelligent prosthetics, intelligent exoskeletons. So these are very useful assistive devices. So one of the important part is that uh, there are like some devices, they are also relying on the algorithms for brain computer interface or interaction. So there is an effort to signal acquisition and processing for brain, and uh, process the signal to identify its discrete features, and then with the help of the AI and machine learning translate it to the command, and the device, say the intelligent prosthetics, will perform the command on behalf of the user. Okay. So I think these days there are also some open data sets, like freely available data sets even, to run your own machine learning models on brain computer interaction data, and data sets available for data collected on different persons with disabilities too. Now there are certain challenges. See, this data is not really like your brain does not really call out, it does not give a speech command that I want to move my hand. And there is, and obtaining the ground truth is very difficult. Like how do you get the tagged data? Because no two individuals are alike, and of course the brain signals are very noisy, so it is not like at a time the brain is sending only one signal. There are real world electrical interference when we talk about brain computer interfaces, because what happens, we are basically tapping into electrical signals, right? So there are ambience noise, there are noise, like there are multiple noises even within the bunch of signals. So how to extract a proper signal, and how to make the training data, how to make the tag data. Okay, these signals spiking mean the individual may wants to move his hand, or forget about that. You may have seen in the movies that by brain signal they understand like what, the individual is communicating by moving an arrow on the screen. Yes for up and no for no. But how it is fast, like, how even you fast calibrate that the arrow will go up for yes, like your BCI system does not know that. So these come, so to do a training in these cases becomes difficult. But anyway, these are very burgeoning field of research and very promising fields too.
Excuse me,
Okay,
ma'am, I have question.
yes, please.
Ma'am, could you please back on the previous slide? Okay. So suppose these particular signals come from in the terms of wave, right?
Yes, yes,
Waves. So how the waves like suppose alpha, beta, delta, theta. So how these waves are converted into the in terms of algorithm. So these wave has own features like suppose uh, alpha. Okay, so 8 to 12 is the heart range of alpha. So how these particular signals comes translate to the algorithm? Is it possible through some machine learning or codings?
yes, yes. Coding. So actually, for brain, as you gave example of alpha, beta, this kind of signal. So for brain, there is something called the event related potential. So if you see any paper on BCI or on the EEG, there are something called, you'll see N300, N400, P20. Okay, so these are
Yeah,
action
okay. ERP,
potentials and
ERP potential. Yeah. ERP waves for.
yes, yes, yes,
Mm.
ERP potential, event related potentials. So by observations, people have correlated that some of these signal matches to particular tasks. Say for language comprehension, they take like N400 or N300. Okay, so by correlating these features of the signal to a particular task, so it is kind of, you can think that the signal attributes are the features and the task are the output uh, at the level of the output. And then by learning a machine learning model or the AI model on them, actually this translation happens.
But ma'am, how they recognize the language, whatever
Okay, so language,
recognize that feature or characteristics of language word
no,
or
no,
a
no.
word, or whatever.
Yes, yes. What? So actually, that's why they have the so the at first, say for the example, this is not particularly related to disability, but say for language comprehension, what happens is first you make a first you take the experiment or the data from say like 100 individuals, showing them a particular word. Okay, and when they are seeing the word, you are measuring the time taken. So you ask them, do you understand the meaning of the word? And they say yes or no, and you are also taking their this the ERP measures through the E through the EEG. Okay, so by correlating these two, like what was the easy output and they were reading these words, we try to understand how different brain sensors or these biosensors are related to the word combination. Was I able to make it clear?
Ma'am, is it like seems like more superficial type?
Not really. Okay, so let me do one thing. But it is difficult to describe it now because I do not have the slides with me. I will come back to you with the slides and more detailed description.
Okay, okay, ma'am. Sure,
Okay. Okay.
sure. Yeah. Thank you, ma'am.
Yeah, yeah. I think others in the class will also find that interesting. Okay. Okay. Yes. So keep questioning. It feels good to know that people are paying attention. Uh, okay, so now let us move to the 3D printing maps. We all know this, like these days we can print this tactile science book, tactile maps, and this really helps persons with disabilities, especially visual impairment, to actually navigate or to learn things, especially for science, anatomy, biology, physics, geography. It helps them. So this is one example of 3D printing that we know. But actually, because whenever we think 3D printing, the first thing comes to our mind is for disability, perhaps persons with visual impairment, because of the ability to render tactile information from 3D prints. But these are also examples of 3D printing which can help in children with dyslexia, children with autism, persons with dexterity impairment. So this you see, this is called a pencil grip. And it may not be the case that this particular child has a neuromotor disability. What happens in children with dyslexia or children with autism, uh, the special educators, they need to teach the children actually to hold a pencil, actually to make grip, to correct their writing style or writing. And there are these small these assistive hardwares which are called the pencil grips. Or maybe that the children is not able to hold the pencil like this in case of autism. So these pencil grips, if you 3D print them in bulk, you can also customize them, and they are not that much costly. But we have spoken to a number of disability organization, like who run schools for children with cerebral palsy, children with autism, and they have said they need to import these pencil grips. I am not sure if these are available in Amazon, but if yes, then also it will cost much more. So this is a see, not every technology should be 3D printed. There is a cost effectiveness trade-off that we need to calculate. But these kind of pencil grips can be made very easily accessible and available by help of 3D printing. So uh, another thing is that this is also an hand grip. These are especially used by person, say, who have dexterity impairment, in a sense that some people with neuromotor disability, they have have difficulty in the fine motor skill. Say moving my hand from left to right, it is a gross motor skill, so I may not have a problem with that. But I need to type out a particular word using my computer terminals. That is a fine motor skill, because I need to do very specific action within a very limited space. Okay, so it requires perfect finger movement. So those who have problems with these fine motor skills and dexterity, they can use a grip like this. So with that, as you can see, that they are able to move their hands but have problems with the fingers. So these can access two fingers. Okay, and these kind of things are really helpful, because I will give you an example. What happens when we work with persons with cerebral palsy? uh, every time to make a software accessible, we need to design on that software. something called a scanning interface as an accessible version, and of course being like academic part people, most of the time what happens is that only the prototype is developed, and then after some point of time, if there is a bug or a problem, it becomes difficult to have a difficult to provide maintenance. But these kind of 3D printed things, the reliance that every time you need to depend on some people who design a special interface on top of a software for the you, that is gone. Because you may be very you will be very but like uh, astonished to know that still the web browsers like the internet, without which we cannot imagine our life, are inaccessible to person with severe cerebral palsy. So they face huge difficulty in accessing in browsing the web. Okay. Uh, Now you can ask me that if the solution is there at least for a group of person, why we don't implement that, or why we don't deploy that? The thing is that again, so there is less the awareness and less funding supports for the disability organization, so that they can go ahead and have a 3D printer and print 3D printed stuffs and things like that. And then this is one of my favorite topic. So games and play. We all like to play. We all like different games, whether it is chess or the Ludo or the snake ladder or the carom board or the video games. We all enjoy that, right? And these are also integral part of our life. So there is a this gaming competition in the tech fest, right? But are these games accessible to persons with disabilities? Accessibility does not only mean the availability of the game in a format that person with a particular disability can access that. Accessibility also means that if such a format is available, as a regular person with disability, will I be able to procure that? Let me give you an example. What is the cost of a regular chessboard? You can go to tech market and get one maybe for 50 rupees or 100 rupees, because it is tech market, right? So so 100 rupees. But what happens for chess, which is heavily played by person with visual impairment, the chess boards need to be designed in a different way. Like instead of just these plain surfaces, they have holes on each of the surfaces, and also each of these piece. If you really see these 50 rupees or 100 rupees chess board, the pieces are not very well marked, because we can see them, we can understand, okay, this is the bishop, this is the knight, this is the king, queen. But if you close your eyes and try to feel them, the tactile sensation won't be differentiating much. But for persons with visual impairment, you need to have a particular tactile sensation, the like, to so that they are able to identify the chess piece. And then at the bottom of each piece there is a protruding part, which you can place on the hole. So basically your chess piece won't move unless you explicitly do so. Now what the same thing there are with the Ludo, or there are even accessible formats for snake ladders with the same hole and protruding part. And maybe these snakes and all, some of these are tactile, like this snake head is basically, you need only information about this end of the ladder and beginning of the ladder, and these two lines, and the snake head and the snake tail, right? So these parts are raised. Now what happens as a result? The cost goes up into 800 or 1000. Now that may not be a problem for a person with a very wealthy background, but just think, like in a typical middle or lower middle class urban or the rural setting, spending almost 1000 rupees to buy a set of Ludo board or to buy a set of chess board, it is not very but it is not very it is not a feasible thing. For chessboard, actually, lot of time what if you see videos, I will give you the links of a person with visual impairment playing chess. Lots of time what they do is that actually they kind of play what we call the blind chess. Blind, like we have maybe seen the videos of Vishwanathan Anand playing chess blindfolded by putting like a black cloth on his eyes. So basically, he was memorizing each moves, and then by words, by the position of the piece on the chessboard. So person with visual impairment plays like that, and there are accompanied people just like scribes in exam. So they give the move on the actual chessboard. So in that case, you can use a low cost chessboard, but always it is not feasible, right? Okay. And then what about video games? So forget about the complicated of the ones. What about even the even the very simple dogma? Like we used to see the almost at like one of the fast video games that a person needs to move and jump over some obstacle and not falling within the canyon or or in the water. So even accessible version of those video games are not there. And to develop a very simple version, it is not that difficult. Actually, the Unity and game design has become easier these days. And once we did, so basically you need to take into account the speeding mechanism. Say if you're doing a car game, so the left turn, the right turn, the action controls that you need to give. I will see that if I have the video that one of my BTech student did. But again, that is the point. We did, but then it get discontinued, right? So there is a need because person with disability, they are also equally eager to play games like us. Then the remote control cars, we have the robotics club, right? In the DIY labs we do many things by using the remote control cars, using Arduino or Raspberry Pi, and writing codes on that. So can these remote operated cars be made accessible, say for example for children with cerebral palsy? So what do we need? Basically, we need to come up with a card with an Arduino board, which we can program by ourselves, and then we need to design the access control in such a way that a person with neuromotor disability uh, will be able to do that. So with like minimum access, so it can be only operated by a left press and a right press, not moving the joystick around by using the special access switches. So these things can be done. There are two aspects of it. First of all, it is never done because we do not generally think about games for persons with disabilities, and also due to the cost component, because the cost goes up. So maybe you can also think about designing assistive toys sometimes in some tech fest, tech competition, or if you feel like. Yes, I do not have answer to the cost part, but maybe at some point of time in future we will be able to bring down the cost much more. So I will just take 2-3 more minutes. So this is the web page of India government's like this startup initiative for disability. It was because the ministries have changed. I am not sure where is it now. But as you can see, there are 50 plus organizations listed with government to develop assistive technologies. But yet the penetration rate is less than 5%. So why is this disparity? We'll talk challenges in the next class, but there are two things. First of all, when you are establishing a startup, so basically we all need to earn some, we all want to earn some profits, right? It is not about whether these are good, bad or things, but if you want to sustain a startup, you need to have some revenue stream. And actually there is not much support for from CSR or government if you want to do it in a very non for profit mode or non revenue earning mode. So that's why, and you can understand, so there is a niche and small market for this. While your technology will be cost as much as an iPhone, some technologies, there will be not as many as users of taking that new iPhone, right? Also, forget about iPhone, a mid-range Android phone, so like 20,000, 30,000. But the market size at that range for assistive technology becomes very less. So earning a revenue from that becomes very difficult. And then will you deny a person with disability access to technology because that person cannot pay? And then comes, if we do it in an academic environment, what about the production support and maintenance? Because there is no provision for that. And then also discussing about disability and assistive technology is highly missing from our academic curriculum. Some universities, they have disability courses, but those are mostly social sciences oriented. On the other hand, just discussing some technologies won't help, because unless we understand the context of how these technologies are going to affect persons with disabilities, uh, or the disability itself, or the assistive roles and limitations of assistive technology itself, um, it will be very difficult to come up with a functioning ecosystem for assistive technology and markets. But nevertheless, still, when you think about doing your own startups, you can think about assistive technology. The Abbas reader that I showed, it is an example that how assistive technology can be part of a efficient startup. Okay, so uh, today I will stop here. Any question? Okay, no question.